Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is section 9.4, multiplicative inverse of matrices and matrix equations. You remember for real numbers, one, the number one is the multiplicative identity for real numbers. Why we call it multiplicative identity? Because if you multiply any real number by one, you get A. You get the number itself. So 7 times 1 is 7. 10 times 1 is 10. So we are asking whether there is a multiplicative identity for matrices. Is there a matrix I in which we multiply A times I and we get A, I times A and we get A? And the answer is yes. But this happens for square matrices because I need IA to be equal to A times I. So for square matrices, we have an identity matrix. And this identity matrix has this form, 1, 0, 0, 1. The main diagonal we have 1, and in the other entries are zeros. If you multiply any matrix by 1, 0, 0, 1 from the left or from the right, you will get the same matrix. So the multiplicative identity matrix of order n would be the matrix In. So you can have I2, I3, I4, always the main diagonal is 1. If you want to write I4, you will have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So always on the main diagonal you have 1 and all other entries are zeros. This is the multiplicative identity matrix. Once we have the multiplicative identity matrix defined, and this is the definition, don't forget, A times I equals A, I times A equals A. We can talk about multiplicative inverse of a square matrix. For the real numbers again, if A is a real number, what is the multiplicative inverse of a real number? It is 1 over A. And why is that? Because A times 1 over A is 1, and 1 over A times A is 1. So what is the multiplicative inverse of 3? It is 1 over 3. What is the multiplicative inverse of 2? Negative 2 over 3. It is negative 3 over 2 because their product is 1, and 1 is the identity element for multiplication. So we are asking the same question for matrices. Is there a matrix capital A and we call it capital A inverse? So when you multiply A times A inverse from the right and from the left, you get IN, the identity matrix for multiplication. If we find A inverse satisfies this definition, then we will call it the multiplicative inverse of A. So this is the definition of the multiplicative inverse of a matrix. If if we have a question like this, show that B is the multiplicative inverse of A. Well, B would be the multiplicative inverse of A if we multiply A times B and we get the identity matrix for multiplication. So to check whether these two matrices are multiplicative inverses of each other, all what we need to do is to multiply them. So negative 5 plus 6, this is 1. Negative 3 plus 3, this is 0. 2 times 5 is 10 minus 10, this is 0. And 6 minus 5 is 1. So we get I2. Also multiply B times A. And you notice in this case, AB would be equal to BA in this case. So there are certain cases in which AB is equal to BA. So multiply 5 3 to 1 by the matrix A, which is negative 1, 3, 2, negative 5, and see what the product is. So negative 5 plus 6, again 1. 15 minus 15 is 0. Negative 2 plus 2 is 0. 2 times 3 is 6. Minus 5 is 1. So again, we have I2. So this is the proof that B is the multiplicative inverse of A and A is the multiplicative inverse of B. Look to A and B. Do you have a method, a quick method to find B if you know A? This is negative 1, this is 5. Okay, we will see how to find B, the multiplicative inverse of A, later. So I leave this for you. Please show that B is the multiplicative inverse of A. Multiply AB and make sure that the answer is I2, and multiply B times A and make sure that the answer is I2. Find the products AB and BA to determine whether B is the multiplicative inverse of A. So if you find that A times B is I2 and B times A is I2, then B is the multiplicative inverse of A. If not, then B is not the multiplicative inverse of A. Here too, find A times B and B times A, and check that this time you will have I3, and I3 is 1, 1, 1 in the main diagonal and zeros elsewhere. Now let us try to find the multiplicative inverse of a matrix. How to find the multiplicative inverse of a matrix? Well, up to now, I know that, let me say that the multiplicative inverse of A is a matrix in which the numbers are A, B, C, D. Okay, so this is A inverse. Now, what is the definition of A inverse? I know that A times A inverse equals A inverse times A equals I2. So let us multiply A by A inverse. And we know that the answer should be 1001 or I2. Okay, multiply 2A plus C, 2B plus D, 5A plus 3C, 5B plus 3D. So this is the product of these two matrices. Now these two matrices are equal. Do you remember the equality between two matrices? What is the meaning of two matrices are equal? It means that 2A plus C should be equal to what? To 1. And 5A plus 3C should be equal to what? To 0. Now, these are two equations in two variables. Can't we solve them and find the values of A and C? Do you remember how to solve equations in two variables? I will solve by elimination method. I have C here and 3C here. So I will multiply the first equation by negative 3. So negative 6A, negative 3C equals negative 3. The second equation remains the same. Add the two equations. Negative 6 plus 5 is negative A. Negative 3 plus 0 is negative 3. So what is A? A is 3. Okay, I have A. Can I find C? Yeah. If A is 3, then 2 times A is 6, plus C equals 1, and 6 would be 1 minus 6, which is negative 5. Oh, good. So let us go back to this equation. I also have 2b plus d should be equal to 0 because of the equality between the two matrices. And 5b plus 3d should be equal to 1. Again, I have system of two equations in two variables. And again, I will multiply the first equation by negative 3. Negative 3 times 0 is 0. Add the two equations. Negative b would be 1. So b is negative 1. So 2 times b, negative 2, plus d equals 0. So d is 2. So now I have A inverse. A inverse is AB. What is A? A is 3, B is negative 1, C, D. C is negative 5, and D is 2. So this is A inverse. So this is a method to find A inverse using the definition, and you can now check that A times A inverse and A inverse times A will give you the identity matrix. Please do the same here. Call A inverse XYZW ABCD as you wish, and use the definition of I inverse of A inverse. A times A inverse is I to find X, Y, Z, and W. But isn't this method uh, not quick method? Okay, it takes some time. So, and what to do if we have 3 by 3 more than 2 by 2? We will see that. But let us concentrate now about multiplicative inverse of a 2 by 2 matrix. Well, there is a formula. If you, this is A, if you take A, B, C, D, if you call A inverse X, Y, Z, W and multiply A times A inverse and put it equal to the identity and solve X, Y, Z, W in terms of A, B, C, D, you will get a formula for finding A inverse. And that's the formula. So how to find A inverse 2 by 2? This is a formula especially for 2 by 2 matrices. Well, A inverse would be 1 over A times D minus B times C. Okay, AD minus BC. And then this is a number. What you get here is a number times the matrix. What do you do with this matrix? A and D, you change their positions. B and C, you keep their positions, but you change their signs. So this is how you get A inverse if AD minus BC is not equal to 0. Because if it is equal to 0, then A inverse does not exist. So let us use this method to find A inverse here in this question. So this is A inverse would be 1 over 2 times 3 AD, which is 6, minus BC, 5 times 1, which is 5. Okay, times the matrix. 2 and 3, we change their positions, 3, 2. Okay, 1 and 5, we keep their positions, but we change their signs. So 5 would be negative 5, and 1 would be negative 1. 6 minus 5 is 1. 1 over 1 is 1. So A inverse is this matrix. Is it the same? Yeah, it is the same. So now you can find A inverse in two different ways, but of course this is easier and quicker. So here he tells you how to find A inverse. Reverse A and D, negate B and C. Let us find the multiplicative inverse of this matrix. So A inverse would be negative 1 times 4, which is negative 4 minus AD minus BC. Negative 2 times 3 is negative 6. Negative 1 and 4 change, reverse. Negative 2, 3 keep, but change the signs or negate. Now, negative 4 minus 6 is negative 4 plus 6, which is 2. So this is 1 over 2 times this matrix. And we know how to multiply 1 over 2 by a matrix. Half times 4 is 2. Half times 2 is 1. Negative 3 times half is negative 3 over 2. And this is negative 1 over 2. So this is A inverse. This is the multiplicative inverse of A. Okay, I leave this for you. Please use the formula and find A inverse. Find the inverse of each matrix. If possible, check that A times A inverse is I2 and A inverse times A is I2. Let us find A inverse for this matrix. 1 over 3 times 2 is 6 minus negative 1 times negative 4 is 4. 3 and 2 change positions. Negative 1 and negative 4 negate. This is 2. So 2 times half is 1. 1 times half. 4 times half. 3 times half. So this is A inverse. What about A inverse of this matrix? Let me write A inverse equals 1 over 10 times 1 is 10 minus negative 2 times negative 5 is also 10. 10 minus 10 is 0. Oh, so 1 over 0 is not possible. So A inverse does not exist. So you see, for some matrices, A inverse does not exist. There is no A inverse because this number is 0. That's it. This is, I will stop here and continue other ideas in another video.